30 years ago, Alan H. Guth, then a young physics researcher at Stanford University, gave a series of seminars in which he introduced inflation into the terminology of cosmology, the science of the origin and development of the universe. The term refers to a brief burst of unusually accelerated expansion that, he argued, may have occurred during the first moments after the Big Bang. One of these seminars took place at Harvard University, where I myself was a researcher. I was immediately fascinated by the idea, and I have been thinking about it almost every day since. Many of my colleagues working in different areas of physics have been similarly interested. To this day, the development and testing of the inflationary theory of the universe is one of the most active and successful areas of scientific investigation. Its most important purpose is to fill a gap in the original Big Bang theory. The basic idea of the Big Bang is that the universe has been slowly expanding and cooling ever since it began some 13.7 billion years ago. This process of expansion and cooling explains many of the detailed features of the universe seen today, but with a problem. The universe had to start off with certain properties. For instance, it had to be extremely uniform, with only extremely tiny variations in the spreading of matter and energy. Also, the universe had to be geometrically flat, meaning that curves and twists in the fabric of space did not bend the paths of light rays and moving objects. But why should the early universe have been so uniform and flat? Theoretically, these starting conditions seemed unlikely. That is where Guth's idea came in. He argued that even if the universe had started off in total chaos, with a highly changeable spreading of energy and a twisted shape, a spectacular growth speed would have spread out energy until it was evenly scattered and straightened out any curves and twists in space. When this period of inflation ended, the universe would have continued to expand at the more modest speed of the original Big Bang theory, but now with just the right conditions for stars and galaxies to evolve to the state where we see them today.